Welcome everyone to my YouTube channel BS Siva, and I am thrilled to have you join me on this incredible journey. In this video, we are going to unravel the topic Hadoop architecture, and by the end of it, you will have solid grasp of the key concepts. Whether you are a curious learner or someone looking to deepen your knowledge, you are in the right place. We have crafted this video to be informative, engaging, and most importantly, easy to follow. But before we jump into the nitty-gritty, make sure you hit that subscribe button and ring the notification bell so you never miss an update from us. Learning is a journey, and we are excited to have you along for the ride. Alright, no more delay. Let's get started with the topic Hadoop architecture. So we already, as we have understood that Hadoop HDFS means Hadoop Distributed File System. It means the data is being stored in distributed manner. Okay, so if I talk about our storage of our data, so the data will be divided into different blocks, and all the blocks will be sent to the different nodes. That is called data nodes. Okay, and so if I talk about this architecture, whatever you are seeing at the screen, this architecture is there is a 4 node. So this will be known as a 4 node cluster. Okay, and just take an example. We have a file of a 500 MB and we need to store this file to HDFS architecture. So we'll see how the file will be saved at HDFS architecture. Okay, so how it will be stored. So initially what will happen, the file will be distributed in different blocks. So the default size of a block is 128 MB. So in Hadoop 2.0 I'm talking about. So in Hadoop 2.0, a file size, like a block size, will be 128 MB. So this file is divided into 4 different blocks, and one block will go to the node 1, and the second node, like I'm talking about second block, that will be saved to a node 2, and block 3 at node 3, and block 4 at node 4 likewise. Okay, so in Hadoop 1 it was 64 MB, like a file size or a block size, but in Hadoop 2.0 it is 128 MB. Okay, now so if I divided this file into different block B1, B2, B3, B4, so it is stored at different block at different data nodes. Okay, and we can see, so yes, so we know that in HDFS architecture there is not only a data node, there is data node. It is a master slave architecture actually. Master slave means master, there will be one master node and there will be one slab node. Not one slab node, but there will be different slab nodes. Okay, and master node will be responsible to store the metadata, and about metadata, as you know about the metadata, about data about a data. Okay, so just take an example. We have a file 1, and that is divided into different block B1, B2, B3, B4, and B1 is at data node 1, data node B2 at data node 2, and B3 at data node 3, and B4 at data node 4. So this data, this metadata is stored at a name node, like means a name node will be responsible for storing this data, and with the help of this metadata only, name node is knowing all the things, like where is the data, at which block, at which data node the data is stored. Okay, So any client is requesting anything, so initially what it will do, it will go to the name node and it will return the request. Okay, whatever the request it is, whatever the client has requested, client node has requested, in response name node will return the response. How it will return the response? It will return the response as per the metadata he has stored, he has. Okay, now on the basis of that metadata, client node will collect the data from different data nodes, as you can see here. So initially what client has made a request to the and name node, and in response in response in response name node is responding with a metadata that is stored at the name node, and client will on the basis of that metadata client will on the basis of that metadata client will uh, go to the different data nodes, and then it will collect the data. If it is visible, like see, initially what happened, like client has made a request to name node, and in response name node responds with a metadata, and that metadata goes to client and on a client node, and after that client node will collect the data from different block, like data node 1, data node 2, data node 3 and data node 4. Okay, so now we can see what will happen if a data node 1 failure or a data node 1 goes down. So it means if a data node 1 goes down, it means we will lose our data. Okay, so to avoid this losing data, or to resolve this problem, there is an option for a replication factor. Okay, so it means uh, Hadoop will replicate your block, like Hadoop will replicate your data block. So you can see a default Hadoop replication factor is 3. How much? It is 3. And so you can see here B2, B2 and B2, like 3 different blocks, 3 different replication for a one single block. See here B3 is also replicated thrice, B4 is also replicated thrice. But is it stored like this way? Is it stored like this way? No, it is not stored like this way, because if it is stored at like a b1 at data node 1, b2 at data node 2 and b3 at data node 3, like this. So what will happen if data node 1 goes down, then what will happen? Again we will lose our data. So to resolve this issue, or to resolve this problem, this replication factor will not be like this. Okay, so what will happen, like a b1, once b1 is stored here, then another b1 block, like a data block, will be stored at a different data node, and another data block will be stored at a different node, at a data node. You can check here like that only, so that if any data node goes down, then also we will have our data safe. Okay, you can see here we will have our data safe. So in that case, now how the metadata will be managed, like see, if you can see here, file 1, where is the file? Like file 1 is divided into 4 different blocks, and that 4 different blocks, like b1 is just stored at data node 1, data node 2 and data node 4. Like that only b2 is just stored at data node 2, data node 3 and data node 4. Like that only b3 is stored at data node 3, data node 1 and data node 2, like that. So this will help us to reduce that fault tolerance. Like if any if any node goes down also, then also we will be able to collect our data from different data nodes. So this is the way Hadoop is storing its data. And replication, like as we know that the default Hadoop replication factor is 3, we can change replication factor as per our business requirement. Maybe our requirement is more than a 3, then also we can manage. We have configuration file. With the help of that configuration, we can change the settings, we can change the replication factor as per our requirement. Okay, so what happens if like in this master and slave architecture, what happens, like if there is a name node and there are different data nodes. Okay, like, and a name node, it every 3 seconds, at every 3 seconds data node sends a heartbeat to a name node. Okay, like data node 1 will send a heartbeat to name node, data node 2, data node 3, and data node 4. So all the data nodes will send heartbeat to name node. Okay, so each data node sends the heartbeat to name node in every 3 seconds. If a name node doesn't receive 10 consecutive heartbeat, it assumes that the data node is dead or running away slow. Got it? So if it is not responding properly, if it is not sending a heartbeat properly, it means name node understand that this node is, just take an example, this node is sending very slow request or very slow heartbeat. Okay, not in like a 10 consecutive way, so very slow. So what will happen, name node will assume that this data node goes down and this data node is not alive or it is very slow. Then what will happen, name node will try to manage all the requests from the rest of the data node available. Okay, so like that HDFS architecture handles this. Okay, now understand, now what will happen if a data node goes down. Then what will happen, if a data node goes down, the replication factor came down to less than 3. Okay, then what will happen, then in that case name node will create one more copy to maintain the replication factor. Even we have only 3 data node left, like data node 2, data node 3, and data node 4. But in case a data node goes down, then we have a 3 data node left. Then what will happen, in this case replication factor goes down. Then what will happen, name node will create another copy of the blocks or data blocks, and it will distribute to the rest of the remaining data nodes so that it can maintain the replication factor. Okay, so now what happens, see here, data node, like the metadata is updated, like file 1 block 1 is stored at where, at which data node, data node 2, data node 3, and data node 4. b2 where, b2 at data node 2, data node 3, and data node 4. Okay, so like this the metadata will be updated. Now we will move to the Hadoop architecture part 2, that is what will happen if a name node goes down. Okay, this is also possible if our name node goes down. Then what will happen, how HDFS architecture is handling these things. Okay, so if a name node goes down means no access to metadata. If no access to metadata means no access to cluster. It means we will lose all the data, all communication will stop from the, if we lost a name node, then only we will lose all the data. We don't know where, like metadata is not there, then how we will know that which data is at which block and how it is separated or how is it distributed? We don't know anything. So no metadata means no access to cluster. And if so, name node failure, what will happen? Name node is a single point of failure in SPOP in Hadoop 1. So it was like this was a situation in the Hadoop 1, Hadoop previous version, not in a second version. In second version, we do have name node is no longer a single point of failure in Hadoop 2. How? So now, like in this architecture, like in Hadoop 2, we have another node that is called secondary name node. What is this? This is called secondary name node. We have a secondary name node in a Hadoop 2.0. Okay. Now, what is, like, if we have a two name node, like one is a name node and another one is secondary name node. So name node is in active mode and another one is in passive mode. Okay. Now, so there are two important files. One is FS image and another one is edit logs. Okay. So this is the work of like to merge these two files and to create a new FS image. This is the part, this is the work of a secondary name node. Okay. So let's say FS image. What is FS image? So FS image is a snapshot of the file system at a particular time. So it means, just take an example. This is some like a 10 or 11 o'clock. Okay. So at this point of time we will create an FS image. Okay. So like that secondary name node I'm talking about. So secondary name node created one snapshot of the current data. It means till 11 o'clock a snapshot is created. Now after that, after the 11 o'clock, new data is coming in the edit logs. Okay, new data is coming. Then what will happen? Again, that older FS image and edit logs, like whatever the data we are generating now, transaction logs I'm talking about, so that will be merged and again it will create another FS image. Are you getting my point? So initially there is this in edit logs there will be current transaction log. Okay, and what will happen? It will like a checkpoint, like it is a secondary. This is just take an example here, secondary name node. Okay, secondary name node comes here, and what will happen? Secondary name node will take older FS image and it will take and edit logs. Okay, and it will merge together both the files or like a FS image and edit logs, and it will create another new FS image. Okay, so this is the work of secondary name node. So secondary name node, if it is not active, then this is working these things like creating logs, creating a snapshot. So name node recovery. So what will happen? If just take an example, if any name node goes down, then what will happen? Secondary name node will become active. Secondary name node will become active and it will work like a name node. Okay, so till the time it is secondary name node is in passive mode. So this is work of merge activity. So it is doing merge activity. So secondary name node performs FS image and edit logs merge to get new FS image. Okay, now secondary name node, once the merge activity completed, the FS image and edit logs reset to empty. Okay, so these things, FS image and edit logs will reset to empty and it will flushed, like this will create a new FS image and after these things will be flushed out. Okay, and this is happening in every 30 seconds, like secondary name node is doing this merge activity in every 30 seconds. This process repeats for every 30 seconds. Okay, this merge activity I'm talking about. Now just take an example, primary node goes down, the secondary name node become active name node, and responsibility of Hadoop admin to introduce a new secondary name node. So if this name node goes down, then secondary name node will become active name node and this will do all the activities all the activities like storing metadata and distributing, and if anyone requesting anything, then it will return the and this is in the it will return the response. So these things will start the like a secondary name node will be start doing these things. Okay, and this will be responsibility of Hadoop admin to introduce new name node, so that this fault tolerance will again work properly. Okay, now we'll understand the replication factor. Now, so understanding the replication factor, as we know that the each block in Hadoop has a 3 replicas. Okay, replicas are stored in different locations. So one replication, like see here, data node 1, block 1 is at data node 1, and block 1 is at data node 2, and block 1 is at data node 4. So this is distributed in different data node, not at only one place. Okay, the replicas location are also updated in the metadata store in the name node. So here you can say there this stores like this location is also updated in metadata. Okay, now this is how replicas are placed. Rack means group. Rack means group of system placed in a different geographical location. So this is one rack 1, and in rack 1 there is this is at different location, this is at different location, this is at different location. There are different data nodes, and one data node is at one location, like data node 1, data node 2, and data node 3 at one location 1, and data node 4, 5, 6 at location 2, and data node 7, 8, 9 at different location. So this is I'm talking about the different geographical location at different okay. So this is a replica pipeline. Replicas of data blocks are forwarded to new location. So it will not see data node 1 will not store all the replicas of a block of a one block. So we'll see it. If I talk about the B1, if name node store data block in a data node of a rate. So just take an example, B1 is stored at a data node 2 at location 1. Okay, now rack the data will not be stored at one location. All the replicas will not be stored at one location. Okay, so if we place all replicas in single rack, there are high chances of data loss if rack goes down. Okay, then what we'll do, we will do each replica placed at different rack is also not ideal solution. So it means if we place each replica at different location, this is also not possible. Why this is not possible? Because two replicas are in one rack and other one replicas at different rack, or vice the balance. Wait a minute. So this is also because each replicas placed in a different rack is also not an ideal solution. The balanced approach is to place replicas in two different racks, because if you talk about the just take an example, any transmission of the data is being done. So this is that if we are collecting data from different location all the time, so what will happen, it will take high bandwidth. Okay, so to reduce that high bandwidth transmission, initially what we will try to two replicas at two different block at one location and another block at different location. Okay, and there you have it, a comprehensive exploration of Hadoop architecture. I hope you have enjoyed this video as much as I have enjoyed creating it for you. Remember, learning does not stop here. There is a whole world of knowledge waiting for you. So keep exploring, keep asking questions, and keep that curiosity alive. If you found this video helpful, don't forget to give it a thumbs up and share it with anyone you think might benefit from it. Your support fuels our passion for creating more educational content. and if you haven't already, be sure to subscribe to DS Shiva and turn on those notifications so you never miss out our latest videos. Thank you so much for watching this, and until the next time, keep learning, keep growing. This is Shiva signing off. Thank you.